Here in the back.
Okay, thank you. So I'm going to talk about deploying 32-bit AS numbers and the work we did at the RIPE NCC. So this is the overview of my talk. I'll give a couple of background slides. I'll skip most of them as Jeff covered them. Then I'll talk about the deployment work, implementation work we did at the RIPE NCC, and end up with some lessons to be learned. Okay, this is what motivates it all. We're running out of AS numbers. This is a plot I made a couple of months ago with the number of AS numbers over time. You see, well, there are 16 bits, so 64K numbers. Goes up nice and smoothly. As of late 2006, we had found 38,000 of those 64K numbers in the stats files. There was some 6,000 in the RRI pools and some 20,000 left. And then you can do some math. Well, I'm looking at consumption rates, and I have a couple of references here. René, Will, and myself presented at NANOC 35. Jeff also presented at NANOC 35. Bottom line is the allocation rate of AS numbers is about 10 to 12 a day. And if you do a little bit of math, you see, slightly depending on the model, that will run out of AS numbers sometime between late 2010 and early 2013. So for the purpose of this talk, I'm going to be pessimistic and assume 2010. So what do we do in 2010? We need more AS numbers. Well, the first thing you can obviously do is try to recover all the unused AS numbers. If you look at the statistics, you see that people get an AS number, use it for a couple of years, then stop using it. So there are lots and lots of unused AS numbers out there. Unfortunately, nobody really knows where they've gone and who is responsible for this. So recovering may seem an option in practice. It will be very hard. The other thing is it will only postpone the problem for a couple of years. It won't solve it. I mean, even if we recover all the AS numbers, well, we can live for another 2 or 3 years, and then what? So the other solution is add a few more bytes to the AS number. So that's why the 32-bit AS number, or ASN 32 proposal came up. That extends the space from 64K to something like 4 billion, and with 4 billion we can live a million years. Okay, there's a proposal. Jeff already showed the draft. It's essentially an IETF proposal to extend the ASN space to 32 bits. There's all these nice features. Main thing is we don't need a flag date, and we can operate in a mixed world forever. So I'll skip the transition mechanism. Jeff covered that. So this is where the details are. The draft is now in the ISG queue. Last time I checked, there was still 1 or 2 details to be fixed. I believe that's solved in the Ref 13 of the draft. And essentially, we're ready to deploy this. So, deploying AS32s. Well, what do you need? Well, first thing is, the draft only says this is how it works. We don't have a policy for handing them out. Then LARs, well, we have to get a policy. LARs have to start requesting them. RARs have to be able to handle those requests. And then you folk have to start using them. That means upgrading hardware tools, test these things, and put it into routine operations. So, a policy for handing out ASN 32s. This is a policy proposal made in the RIPE region, and similar proposals were made in the 4 other regions. And it is in essentially 3 steps. The first step is now starting January 1st of this year until the end of next year. During this period, folks asking for an AS number can ask for either an ASN 16 or an ASN 32. The default will be that you get an old 2-byte or 16-bit one. But if you really ask for, you can get a 32-bit one. That will flip on January 1st, 2009, when you can still ask for both, but hopefully everybody is ready, all the routers and all the code supports it. So the default will be a 32-bit AS number. Only if you specifically ask for it, you can still get the 16 one. Well, then we'll continue for another year. By that time, we'll run out. And after 2010, you always get a 32-bit number. Other thing that's important to notice, this is the only change in the AS allocation policies. All the other things remain the same. So, like I said, this proposal was made in the RIPE region. 4 similar proposals were made in the 4 other regions. Consensus was reached everywhere as of late last year, and it's been a policy in all 5 regions since January 1st of this year. When these policies were submitted, as one of the RRRs, we started to realize that we have to start handling requests for ASN 32 as of January of this year. And the other thing is that we also have to, you as an LIR have to be ready to use these AS numbers as of January 1st, 2009. So we started looking at this, and people asked me, well, I have an AS, so why should I care? Well, maybe you shouldn't. On the other hand, lots of you folks build sites for customers and give them equipment, address space, and whatever. And yeah, there you have to be ready for handling ASN 32, since your new customers will use them. So back to the RRRs. Oh no, back to the... okay, the policy is now in place. You can request an ASN 32. And if you do this at the RIPE NCC, there is this thing called an AS number request form. Looks like this, some general information, and there's a field supplemental comments. And the only thing that changed there was if you want an ASN 32, you simply write that in the additional comments section. I want an ASN 32, and the please is optional. So that's for RIPE NCC. What about the other RRRs? Well, details vary, but essentially it's the same thing. You just ask for it. Then, at the RIPE NCC, we saw this coming, and we started to look at this. And, well, the first thing we noticed, well, our registration systems were designed for 16-bit numbers. That's forms, tools, databases. We have this thing called the LIR portal, which allows people to manage their resources online onto a web form. Lots more. All this was designed for 16 bits. And then we looked a bit further, and we found out that, yeah, we use AS numbers in lots and lots of other places, like our peering script, our routers. We have a device called the RIS, which collects routing information. We have a thing called the routing registry consistency check, which compares routing registry information with what's seen on the net. That's all in 16-bit ASs. We provide all kinds of statistics. Those use 16 bits, and probably more. So we have work to do. So we started looking at implementing this. And the first thing was about a year ago, when we went through all our systems, documents, procedures, and we looked for all the places where the word AS popped up, and we defined what had to be upgraded. And we worked quite a bit, since we ended up with work item for 7 departments in the NCC, and about something like 1.5 to 2 million years of work. Well, then we set up a team to do the work. This team started in August and had the goal to be ready into early 2007. And we'll see in a second if we succeeded. So here's the team. I'm not going to read all the names. It just shows you, in bold it's probably more interesting other departments. See, it's pretty much a digital company. Software and registration services is obvious, but we have training materials. They use ASs all over the place. Finance, we build people based on the resources they hold. So, hey, if you have something new called a 32-bit AS number, that has to be adjusted. Well, and a few other departments. That's a lot of people, lots of departments involved. So this team started in August, and the first problem it hit was the notation. And surprisingly, this is not specified in the draft how you actually write those numbers. So people used a column, one column B, Well, for this number, so before the column is the highest 16 bits. Well, the problem is that it works, but it's very easy to confuse this with community strings. So we needed something else. So there's another proposal that's in the Michelson draft, which essentially uses this dot. So ASX for the 16-bit numbers and ASZ.Y for 32-bit numbers. Advantage of this, it's different from all other BGP attributes. It also has been informally accepted by one vendor, and the RRs have accepted this. There's an open question in the draft: is 0.323 a valid notation, or should you drop the leading 0? Current answer is yes. And well, since this is IETF work, it's a work item for the Interdomain Routing Working Group. Unfortunately, well, there were some comments on the mailing list, and there is no consensus, and this whole draft has been put on hold. Well, so for the time being, we just assume that this format will be used, but it's still an open question, and it may affect our work, and we may have to redo things later. Well, we accepted that. Then, the next thing we hit was, okay, we now have to know how to write these numbers. We have RPSL. RPSL, Routing Policy Specification Language, was written with ASN 16 in mind, never thought about 4-byte ASs. And so we had to extend that. Now, RPSL has its extension mechanism, and our first thought was to use this. On the second thought, this didn't look like a good idea. The problem is, you can introduce those extensions, and you end up with 30 new attributes. And basically, you would end up with an ASN 30 equivalent of everything that's already there. And that would be fairly impractical in your code, since you would have to check for all the attributes. Well, first for the 16-bit one, then check if there's a 32-bit one, then convert, and on output do exactly the same. So that's highly impractical. So we wrote a draft to change the language using essentially the same notation as the Michelson draft. The thing we added there, just for convenience, was that on output, leading 0 must be dropped, and on input, it may be accepted. This is a bit of work. It means a bit of work, since people will have to upgrade their tools. On the other hand, you only have one attribute for everything, whether it's 16-bit AS or 32-bit ASs. It's a one-time exercise. There's a list, and there's a list of affected attributes in the draft, so you can just go and look at your code and check. This draft is an individual submission, but I welcome comments on the RPSL NG list. That's the place where it's being discussed. Okay, so then we know the notation. We started to look at the software. Well, obviously I won't bother you with the code, since it's all very NCC specific. But the things you have to look at, also if you have your own systems that deal with AS numbers. Obviously, parsing AS numbers on input, formatting on output, and the main danger there is that some languages, Perl for example, will treat x.y as a floating point number without warning you. Because if you do it in C, yeah, it will break, since it doesn't know the dots. In Perl, oh yeah, that's a floating point number, we'll live happily forever. The other thing, make sure that you have sufficient bits in your code. AS numbers have been 16-bit forever. And people have probably written code using unsigned shorts ins. Well, that will break immediately. But people have also been using regular ins. So by the time we're halfway through the 30-bit to ASs, these numbers will break. Then we have all kinds of routers. Well, we both have hardware routers in the office and software routers. We asked vendors, well, the state is Juniper and Redback have officially announced implementations. Unfortunately, that's only for their high-end versions of their operating system and their high-end routers. The lower end routers, they claim, will be available early 2007. Cisco has an implementation, but it's not official. And again, it's only for high-end routers. It's not for the vanilla routers. And the ETA for the low-end ones is unclear. So that set us back a bit since, well, we couldn't upgrade our routers. It also points out a bit of a chicken and egg problem. The comment from these vendors is that nobody from the current operating community has asked for 32-bit AS support, so they've put it fairly low on the list. On the other hand, if you look at this, who is likely going to use this? This will be the folks who build the network 1, 2, or 5 years from now. So essentially, those will be your future customers. Site comes, buys a Cisco off the shelf, and says, "Hey, I want to be an AS and connected to the internet. You as service provider, please arrange this." And then, yeah, hey, you find out that the router doesn't support this, and you still get a 32-bit AS number from your registry. So, as operators, you should mention this to your vendors and say, well, maybe we don't need it, but our future customers will need this. If you use software routers, things look a bit better. In Quagga, there's a patch, and this is the URL. We were testing the patch in the office. It seemed to work. There was one bug when I wrote the slide on January 12th that has meanwhile been fixed. The bug at the time prevented us from upgrading the routing information service. So that now that the bug is fixed, we will do that shortly. OpenBGPD, as Jeff mentioned, the patch exists and has been successfully tested. So if you use software routers, you're much better off. Supporting systems. Lots of people use Nagios. Nagios uses the BGP MIP, and the BGP MIP has been written with ASN 16 in mind. There's a draft in the ITF specifying an update. Unfortunately, it expired. I asked the author, and he said, "Yeah, well, when I have time, I'm going to work on this again, but people haven't been bugging me for this." So this is the thing. If you use this MIP, use Nagios, use this MIP, mention this in the IDR working group. It needs to be revived, and it needs a bit of push from the community. And even if you're not using the Nagios, if you use the BGP MIP, well, it's the same thing. RIS, I already mentioned this. Then we have lots and lots of other things. I won't mention this in detail. Our WHOIS database has software, needed a major upgrade, and all kinds of practical things. Trading material. It specifies AS numbers, specifies them as a 16-bit number all through the places. We have to just go through every slide and every page and upgrade it. Again, that's something you will have to do as well if you have information for your customers. Same goes for documentation. And then we had all kinds of little scripts lying around that did things with AS numbers like statistics, billing, consistency check, all those things. We had to go to the software, upgrade them. And this is something, well, obviously you won't have these scripts in your environment, but it is something you will have to do. Make sure that this is handled correctly. So we did some planning. Like I said, we had to be ready early 2007. And yeah, well, did we succeed? And the answer to that one is yes. We said this, we will be able to process requests for ASN 32s. On January 1st, actually New Year's Day, somebody sat down and submitted one. So we started, well, we don't work on New Year's Day. We started working on this the second day. And it was processed and allocated. We allocated AS 3.0 on January 2nd. And just to prove this, if you query our WHOIS database, you can actually see this now, this entry. Internet 2 in Germany got AS 3.0, and it's actually using it. Okay, do we see it on the net? Well, we don't see this one on the net. We do see other ones like the one Jeff mentioned in his talk. Well, this is a snapshot on the RIS, where in the third column on the right, it shows the AS paths we see, and in the second column on the left, we see prefixes. And we see a couple of instances of this transition AS 23456 pop up. So yeah, we do see them in the wilds. Unfortunately, well, we cannot tell which of the three AS is handed out at that point. It really is, since we only see this transition AS. Though of course we can guess from the prefix. Now that this policy has been in place for months, are people asking for 32-bit ASs? Yes, they are. I checked the statistics yesterday afternoon, and as of February 5th, 13 ASs were allocated, 16 in the RIPE region, 4 in the APNIC, and 3 by ARIN. So, status, well, we still have a little bit of work to be done, but essentially we have completed this. And just to finish off with a couple of lessons to be learned. Well, been working on this for about half a year now, and upgrading to ASN 32s is definitely not rocket science. It's relatively straightforward. On the other hand, it's a lot of work. ASNs have been 16 bits forever. So when I look back at project reports, I see that we indeed spent something like 1.5 to 2 man years of work divided over the whole company. Of course, we're a registry, so we do a lot of things that most people don't do with ASs. But we do operate a medium-sized network. So I took out all the work that's related to registration of ASs and just looked at our network. When I do that, we end up with something like 1/2 to 3/4 of a man year of work, which is still a significant amount of work. And if you operate a medium-sized network, it's definitely something you should be planning for. So that's, I think, the main lesson. You should start thinking about this now. Ask vendors for support. If the vendors won't support it, you'll have a nasty surprise in 2009 when you get a 32-bit AS number for a new customer and realize that you cannot type it in on your favorite router. And the thing you definitely shouldn't be doing is wait until you get assigned something like 1.5432 in 2009 and don't have any idea what to do with this number. With that, are there any questions?
Hi, John Scudder, Juniper. You mentioned about halfway back in your talk about the representation format, and do we use some dotted format or whatever, and that it had been posed to the IDR list and no consensus formed?
Yep.
So I guess I have an observation and a question. The observation is my reading of the conversation that went on IDR on the list. It's true that the chair didn't, declare consensus as this or that, but the, vast preponderance of the comments were to the effect of, gee, why can't we just use a 32-bit integer, just continue the integer representation? So that's my observation, is that to my eye there was a consensus. And then the question is, why can't we just use an integer representation?
So yeah, I think that on the IDR folks, mainly people spoke up who were in favor of the big integers. And to answer your question, well, there's no really good. There's no argument why you cannot use a big number. I would personally think that something A.B is a little bit more convenient, just like you use dotted quad for IP addresses. But there's no argument in favor of one notation or the other.
Okay, thank you. I guess given that that conversation doesn't really seem to be over yet, it might be useful for operators to chime in on either the IDR list or any place that draft is being floated, unless the draft is just being withdrawn.
Yeah, I agree. I mean, it's definitely. I mean, if people have feelings about this, they should definitely speak up on the IDR list, so we can close this issue.
Thanks.
Hello, Anton Capella, 5 Nines Data. The gentleman standing behind me is probably going to fill you in more on this, but I wanted to point out that of this year, first day of February, Bill posted a comment saying that the last call resulted in consensus that this notation is not desired on the datatracker.ietf.org website. And I'm sure you can fill us in on the remainder of it.
Okay, I had not read that one. So where did he post this?
But
Oh well,
I
we
mean,
have to.
it was my interpretation of the discussion of the last call. I mean, if you look at the last call that happened, there were a lot of people saying, I don't think we need this, I think the dots will cause trouble, and a small number of people who, I mean, I think the arguments against are pretty reasonable, including the one that I didn't see, but that you experienced, that the floating point, sometimes they would be silently interpreted as floating point numbers. I mean, that's pretty dangerous. And then, you know, you have to quote them in regular expressions, et cetera, et cetera. And the argument for really is pretty weak. How fast are we really going with the AS numbers that we're going to get, you know, more than 6 digits? And 6-digit AS number is going to be 6 digits, whether it's 1 digit dot 5 digits or it's 6 digits, right? The only place where A dot B really saves is where B happens to be small. So I think that, you know, I don't think there's a real strong argument for the dotted notation. I think there are some reasonable arguments against it. And so it would be nice to see this actually resolved if there are any strong arguments for the dotted notation.
Okay, yeah, Philip?
Yeah, Philip Smith, Cisco, slight change of subject, just one little nit for your presentation. Cisco implementation iOS XR 3.4 is very much official, and it does have 32-bit AS numbers.
Okay, yeah, that probably changed recently. I mean,
It runs on all of the GSR.
okay. Yeah?
Hi, Chris Whitfield at NRAP. One thought as far as the A.B notation is that theoretically it could be possible to actually carry information on the left-hand and the right-hand side. I mean, I'm thinking in terms of maybe, you know, the 16 bits on the left-hand side determining an ID of the RIR that allocated the ASN, and then the right-hand side with the, I mean, I can see how that wouldn't work. I can see how that could work because that limits the number of ASNs, but, you know, that's something that could be used. I mean, and one argument for the dotted, I don't know if anyone's ever brought that up before.
Yeah, well, that's something that has sort of unofficially happened. Since if you look at the 5 registries, PNIC got 2 dot something, RIPE NCC got 3 dot something, and I believe ARIN got 1 dot something, and the 2 others got the other one. So at the moment, you can see, if you see 1 dot something, you see that ARIN originally assigned this.
Let's make this the last question, okay?
One more clarification on Cisco's delivery of the 4-byte ASN on vanilla routers. So we are looking at the calendar year of 08 for the official release, and unofficial release maybe sooner than that.
Sorry, I didn't get that acoustically.
Sorry?
So I didn't hear it. I couldn't understand the comment up here.
Okay, sure. So Cisco's release for the 4-byte ASN on iOS would be in calendar 08. Official release, and unofficial release will be sooner than that.
Okay, thank you.
All right. Thank you, Henk. Appreciate that.